July 24th, 2017, here in Selby, getting these ready for you in October when I will be in Germany. A couple things I have to, this is take 4, by the way, take 4. So hopefully we got it right this time. A couple things we just want to review a little bit before we get into the more difficult problems. Average rate of change problems. Whenever you see that word, those words, rate of change, you should be thinking a slope, a first derivative, an f prime of x, a g prime of x, an h prime of x, a rise over run, something like that. However, that word average in front, that changes everything. Average rate of change, this is this generic formula that you've already learned. We want to find the average rate of change, the average slope of a function from over the interval from a to b. My generic formula will then be f of b minus f of a over b minus a. What I've got to grab right away. On this problem, here's an example. My curve is the parabola, f of x is x squared plus 2x minus 6. And we want to find the average slope from where x is negative 2 to where x is 1. The negative 2 is included, the 1 is not included, but 0.9999987246589 is included. It's so close that it doesn't make any difference. Almost sprained my ankle here. So going to the formula, I'm going to put down immediately f of 1 minus f of negative 2 over 1 minus negative 2, just going to our average rate of change formula. I need an f of 1, there I did the arithmetic, to get a negative 3. I need an f of negative 2, there's my work, to get my f of negative 2. Okay, carefully, f of 1 we found is negative 3, f of negative 2 we found is negative 6. Be careful with your signs, you should get 3 over 3, which is a 1. So that means the average slope on this problem is a 1. The average slope on this interval would be a positive 1. Some other things I want to talk about quickly that you already know from pre-calculus and a little bit this year. 180 degrees is the same as pi radians. That's going to help us on the problem over there. 30, 60, 90 triangles. We know this. If that shortest leg is 1, hypotenuse is twice as big, which would be a 2. If you can't remember this one, use Pythagorean theorem. But I remember it, it's square root of 3. 45, 45, 90 triangles. If a leg is 1, your other leg also has to be 1. If you can't remember the hypotenuse, use Pythagorean theorem, but we'll come up with a square root of 2 for that. Okay, then our sine curves and cosine curves. The sine curve looks like this. This should be a half a circle, and this should be a half a circle. Art was never my forte. But from 0 to 2 pi, we can give our values here. And that's going to help us on one of our problems over there. And here's our cosine curve that we need to memorize also. And some of you probably use the unit circle, some of you teachers out there, I should say. And that's fine. I haven't been the biggest fan of unit circles, so I usually go back to these things instead of doing that. Hope I'm not doing a disservice to my students once they get to college and their professors expect them to use the unit circle. But they can be taught that when they're in college also. Okay, my assistant today, I like the way she's dressed. Jess, come here. You're like this. Huh? Huh? Look at that. Look at that. Charlie, how do you like that? Okay, I'm not dressed Duke-ish, so you see my back. Kyrie Irving went to school at Duke. Okay, thank you, Jess. Okay, now we will move to the other board. My producer wants me to move this.
Okay.
All right. We did an average rate of change problem over there. Pretend I haven't put that X through that yet. It says find the average velocity. This is the position. The particle, whose position is x of theta equals 2 times cosine of theta. That's the position of the particle at any time theta. Okay, if this is the position and I'm finding the velocity, you've been taught in here we take a first derivative to get that velocity. Okay, however, because of this work, average, and then also because of this, if this is position, that's velocity, that is a first derivative, that is a rate of change. So that does make this an average rate of change problem. So I'm going to be grabbing the f of b minus f of a over b minus a, but in a little bit different form. And instead of f, we're going to use x. So this is going to be x of, see my interval is 2 pi to pi over 2. So x of 2 pi minus x of pi over 2. So this is really f of b minus f of a over b minus a. Now we need an x of 2 pi. So if I grab my x function, x of 2 pi equals 2 times cosine of 2 pi. And copy this 2 down. Cosine of 2 pi from our cosine curl over here. I'm not going to copy it again, but we can see that we're up 1. So that's going to be a 1. 2 times 1 is a 2. Now I need x of pi over 2. So I'm grabbing my cosine function again. Whatever's in parentheses is what I put in for theta. Theta is my variable of interest. Again, I'll copy my 2 down, then cosine of pi over 2. I can get from my cosine curve over here again that we looked at a bit ago, and that's going to be a 0. 2 times 0 is 0. Now I'm ready to finish the problem. X of 2 pi we have is 2. X of pi over 2 is 0. In the denominator, even though I'm colorblind, I like grabbing a different color.
That's not a different color. That's still red. Good thing you got me here.
Yeah, my assistant told me.
There's a different color.
Where do I put my black on?
There it is.
I don't know, I might have to get a different director. But thanks for sharing that red one was not a different color than the other red. I need the same denominator. There, now I've got the same denominator. So 4 pi minus one of those pi's will give me a 3 pi over 2. I have a complex fraction. I might deal with it this way. Instead of dividing by 3 pi over 2, I'll multiply by the reciprocal. And we'll come up with an answer of 4 over 3 pi, which is a funny looking answer, but that is the average velocity of that particle on that interval. Let's see what this looks like on the graphing calculator. Jess, can you first go to the home screen? And punch out 4 divided by 3 divided by pi.
Move that up, though. Because that's in the way. That arm is in the way. There.
Okay, punch out 4 divided by 3 divided by pi. And that'll be about a 0.424. To the nearest thousandth. Okay, to see what this means now, if Jess hits, I'm going to do this, Jess, that'll help me that a little bit. Okay, if Jess goes to her y equals and punches in our original, 2 cosine of theta. Okay, window. Let's go from, I think you're there already, the pi over 2 to the 2 pi, yep, we're already there. Window, and y, she went -3 to 3, so we're fine there. If she hits graph. Okay, what she has punched in there, that's our position function. X of theta, looks like that. Okay, we found the average velocity, which is the average slope, is a positive 0.424. Here we have a whole bunch of positive slopes. Here would be a slope of 0. On this other side, we have a bunch of negative slopes. Those are all negative slopes over here. And at the end there, at the end point, we might have another slope of 0. But I see way more positive slopes than negative slopes. Okay, so I'm not surprised at all that my answer is a positive number. I would have had no idea that my answer would have been a positive 0.424, but I am glad that it's positive. The average slope on there, we see way more positive slopes than we do negative slopes. My final answer had better be a positive number. All right? Next problem. Let me just summarize yet with this one a little bit. Average velocity. If this is position, usually we would take a derivative to find the velocity. However, because of that word average, this makes this an average rate of change. Velocity is the rate of change of what was given to us, which was the position. So that's why we're going to this formula. Going to that formula, and it's just a matter of figuring those out, substitution, a little bit of math work. That's not a 2.2, it's a 2 times 2. We kind of mess out of that. Well, okay, let's go to our next problem. Enough summarizing. Oh, the wheel fell off. Jess? Okay, you got to hold that wheel right there. Come down here. Come over this side, over this side. Hold. Oh, you got to grab on that wheel. Hold it in. There. Okay, yes.
Okay, where are we moving this?
I'm not going to move it anywhere. I'm going to kind of leave it here. So, just want to get it out of the way a little bit. This next problem. That card is older than I am. We don't need any jokes about it. I know I'm old. Okay, next problem. Find the average acceleration of a sneaky particle. All particles are sneaky. That one back there was sneaky also. Particles, they'll go to the right for a while, they'll go left for a while, they'll go up, they'll go down. You can never trust a particle that are sneaky. So find the average acceleration of a sneaky particle whose velocity is v of t equals sine of 4t over the interval from pi over 24 to pi over 16. They gave us velocity. Normally, in normal times, if I knew the velocity, I would take the first derivative to get acceleration. But because of this word, I'm not going to have to take a derivative. It's the average acceleration. Acceleration is the first derivative of velocity. Acceleration is the rate of change of velocity, so this changes this into an average rate of change problem. So we're grabbing that generic f of b minus f of a over b minus a formula. Instead, this time it's going to be velocity of pi over 16 minus velocity of pi over 24 equals, or over pi over 16 minus pi over 24. There we go. I need a velocity when the time is pi over 16. Four times pi over 16 pi over 4, pi over 4. I'm going to have to do this. You can still see me here fine, right? Is this thing in the way?
Just of your face, but.
Just on my face.
Yeah.
Good. Just on my face. Okay, so 180 degrees is the same as pi radians. We want a pi over 4, so I'm going to go like this. 180 divided by 4, that's going to be 45 degrees. So pi over 4 is the same as 45 degrees. I always say in calculus or in radians 99% of the time, but here I'm going to go back to your comfort zone from geometry. We'll go to the degrees. So I need the sine of 45 degrees. We reviewed over there a while ago. Our 45, 45, 90. If this is 1, that is also 1. The hypotenuse would be square root of 2. SOHCAHTOA. We want sine of pi over 4. Sine means opposite over hypotenuse. So from the 45 degrees, this is my opposite. That's my hypotenuse. So that's going to be a 1 over square root of 2. I've taken care of the velocity when the time is pi over 16. Now we need the velocity when the time is pi over 24. Okay, once again, it's going to be 4 times pi over 24, and the 4 to the 24 should reduce to be a 6 in the denominator, so that's a pi over 6. 180 degrees is the same as pi radians. This time we want pi over 6. So if I divide by 6, that will be 30 degrees. So what I want now is the sine of 30 degrees. So let's go back to our 30, 60, 90 triangle, which we just reviewed on that other board a minute ago. If that's 1, that has to be a 2, and that's a square root of 3. Sine means opposite of hypotenuse. So from the 30 degrees, the opposite is 1, the hypotenuse is 2. That's going to be a 1/2. Now we're ready to go back to our formula. Velocity when the time is pi over 16 is 1 over square root of 2. Velocity when the time is pi over 24 is 1/2. Okay, and we have this. That's a mess, isn't it? Let's go to what you learned in pre-calculus for me, or else in Algebra 2 from Mrs. Roush. And here's what I would do with this problem. My least common denominator, looking at all those denominators, if I had a 2, a 16, and a 24, 48 would be my least common denominator, then I've also got that square root of 2. Okay, so I'm going to multiply by 1 in that form. My square roots of 2 will cancel, so I get a 48. 48 divided by 2 is 24, so I have minus 24 square roots of 2. In my denominator, 48 divided by 16 is 3, so that'll give me 3 pi, and don't lose that square root of 2, so that's 3 pi square roots of 2. And 48 divided by 24 is 2, so that'll give me 2 pi square roots of 2. Okay, at least I don't have a complex fraction now. Numerator, I'm going to leave it the way it is. Okay, denominator, there's 3 of these pi square roots of 2, minus 2 of these pi square roots of 2 would give me just 1 of those pi square roots of 2, and I'm going to quit right there. That's a decent look. It's not a good looking answer, but it's good enough. Don't you dare cancel those square roots of 2, because that square root of 2 is not times the rest of the numerator. We're done right there. In a pre-calc in Algebra 2, we always said you can't leave a square root in the denominator. Well, we were fitting a little bit. In calculus, it's okay to leave it down. Okay, but that would be the average acceleration for that sneaky particle from pi over 24 to pi over 16. There's a lot going on in this problem. You have to know something about radians and degrees. You have to know about sine, cosine, tangent, SOHCAHTOA. You have to know something about 45, 45, 90s, 30, 60, 90s. You have to know that it's an average rate of change problem. You have to be able to work with a complex fraction. A lot to do there. If you can do that problem, you're pretty good. Okay, we have one more problem to do, and that's going to be quite a bit different from the first ones. So Jessica, can we slide that? Are you okay just keeping that there? You think that'll be good? Okay, completely different problem here. Okay, find the points on g of x where the line tangent to h of x is perpendicular to g of x. First of all, I see the points, that s in parentheses, so that means it might be just 1 point, or it might be more than 1 point. Actually, in this one, I think we're going to get 2 points because I already looked at the problem. Okay, the line tangent to h of x is perpendicular. If you ever see the word parallel or perpendicular, you're going to be thinking, now what does that have to do with calculus? Calculus, we work with slopes a lot. If two lines would be parallel, we'd say, well, they have the same slope. This one, it's not parallel, but it's perpendicular. And if two lines are perpendicular, what I know is the slopes are negative reciprocals. If this slope is a positive 3 over 2, then this slope would have to be the negative of that, and the reciprocal of that would be a negative 3 over 2. And that's what we should think as soon as I see this. Perpendicular, the slopes will be negative reciprocals. As a matter of fact, I'm going to write that down as soon as I see that. Slope is negative reciprocals. All right, let's go to our h of x and find the slope over here. This is an algebra 1 problem. H prime of x, my slope would be a negative 1/3. Negative reciprocals, so the slope that I want to use then on this problem, my perpendicular slope would be the negative of this, and the reciprocal of this, so that's going to be a positive 3. Now let's go to our g of x function. Let's find the slope, first derivative. Old stuff, easy stuff, power rule, move the 3 out front, the 3's cancel, I'll get x squared. Move the 2 out front, the 2's cancel, I'll get plus x in first power. Derivative of this would be a 1. Derivative of my constant is 0, so that's gone, so there's that slope. Okay, now we said these slopes would be negative reciprocals of each other. So this is the negative reciprocal, so x squared plus x plus 1 has to be the same as that 3. Okay, that's a connection you have to make to finish this problem. Okay, the rest of this is basic algebra 1. I can subtract 3 from both sides. I can factor into x plus 2 times x minus 1. And we'll come up with x could be a negative 2 or x could be 1. Okay, let's go back. They said find the point, so I need the y number. If I put the negative 2 in, whoa, I don't want g prime, I just want g. Got to be careful there. G prime would have been a lot easier. I'm going to do a little fraction work here. If I put the negative 2 in, that would give me a negative 8 over 3. If I put the negative 2 in, that will give me 2. If I put the negative 2 in, that will give me minus 2, then minus 3. From here, I can do this. These two will cancel each other out, so negative 8 thirds minus 9 thirds would give me a negative 17 thirds. And you just found your y number. My x number is negative 2, and my y number is negative 17 thirds. Okay, so that's one of those points. That'll be one of my answers. We'll show you with the graphing calculator how one of these works in a bit. Okay, to get my other one, I need to this is my x number, I need to find my y number, so back to here again. Okay, and it goes into the original function, the 1 does. If I put the 1 in, I'll get 1/3 plus 1/2. If I put the 1 in, I'll get plus 1 and minus 3. I'm going to do this. A little fraction work. Okay, now I've got 6 for every denominator. 2/6 plus 3/6 would be 5/6. This would be a negative 2 times 6 is negative 12. 5 minus 12 would be a negative 7/6. And Colin, what's that? Yep, that's my y number. My x number is 1. My y number is negative 7/6. So these 2 points are on the g curve. The points have to be on g of x. That's why I had to come to g of x to get my y number. Okay, and should be perpendicular to the g of x there. All right, let's just look at one of these with a graphing calculator. Turn us a little bit again, Jess. Do some major erasing here. She's at her y equals, she cleared that out of there. Does that look okay? All right, so punch in our g of x, which is x to the third, divided by 3, plus x squared, divided by 2, plus x, and minus 3. Go down to your y2 and punch in negative 1x, divided by 3, plus 5. Jess, I told and okay, hit trace 1. No, hit trace negative 2. My fault. Okay, and look what it shows us over here. I don't think I like that number. Negative 2. Oh yeah, I do like that number after all. The point we have over there is negative 2, negative 17 thirds. Negative 17 thirds would be negative 5 and 2 thirds, so we are okay there. Okay, now we're going to draw a tangent from this curve. Okay, so second draw. It's right in the middle of the program thing. Okay, we want to draw a tangent, so that's number 5. Okay, we want to draw a tangent at x equals negative 2, so negative 2, enter. Okay, and there's the tangent. This line right here is the tangent. That's the tangent. Okay, does that look like that's perpendicular? This line make a right angle? I think that it does. If we wouldn't have hit the zoom square, it wouldn't look like it's perpendicular if we just did zoom 6, but it does. We're not going to do it because there will be too many lines in here. We could draw another tangent over here, but it gets kind of too packed in, but just to show you what we found here. Okay, and this will help you in homework 27. Homework 27. Jess, anything else?
Go Duke.
Go Duke, she said. I like that girl. Okay, thank you, and we'll see you at the next filming.